Welcome to the example about coffee temperatures with confidence intervals for a mean. In this problem, it says you randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperatures is 162 degrees Fahrenheit with a sample standard deviation of 10. Construct a 98% confidence interval for the population mean temperature of coffee sold. So assume the temperatures are normally distributed. So out of those 16 coffee shops, assume 1 cup of coffee per shop. That means our sample size is going to be 16 cups of coffee. Our sample mean, X bar, is going to be 162 degrees Fahrenheit. And our sample standard deviation is going to be 10.0 degrees Fahrenheit. We're going to need to construct the 98% confidence interval estimate for the population mean temperature for all coffee sold. Our best point estimate is our starting point. Our starting temperature should be our sample mean, which is 162 degrees Fahrenheit. The margin of error then will come from using the formula E equals T critical value times S divided by square root of N. We have our sample mean or sample standard deviation S above, and we have our sample N. Since we're doing a confidence level of 98% and N is 16, our degrees of freedom would be 15. Remember, it's 1 less. So looking on our chart, we need to find our critical value. Okay, so let's see. Our degrees of freedom is 15, so in the first column, go down to 15. And then to find our T critical value, you go over to the 98% column, which is the 4th column over, 2.602, I believe. Making sure I got that right. Yep, 2.602. Great. Now we can just substitute them in. E equals 2.602 times S, which is 10. I'm just going to abbreviate it 10 divided by square root of 16. Let me go ahead and make this a little larger for everybody. There we go. On our calculator, we can go 2.602 times S, which is 10 divided by square root of 16. There we go. And we get E, the margin of error is 6.505. And remember, again, your units need to include the same units as our problem, so this is degrees Fahrenheit. So margin of error, degrees Fahrenheit. Now we're going to construct the confidence interval. So we need our margin of error, E, and we will need our best point estimate, X bar, to combine those two. Let's see how this looks. We're going to go X bar minus E less than mu less than X bar plus E. So X bar is 162 minus a margin of error, 6.505, less than mu less than 162 plus 6.505. So I'm adding and subtracting the margin of error from the best point estimate. Now let's go ahead and do the subtraction in addition. So 162 minus 6.505 and 162 plus 6.505. There we go. Get those two answers. So it's 155.495 less than mu less than 168.505. Let's do the interpretation. The interpretation in our sentence is going to be we are then the confidence level is 98%. We are 98% confident. The population, we're doing a population mean. Temperature for all coffee sold is between between, let's see, so it's 155 point, we'll do 2 decimal places, 50, and remember our units, degrees Fahrenheit, and 168.51 degrees Fahrenheit. Again, our sample mean was 162, which is obviously right in the middle of that interval. We're taking our sample of 162 and estimating a range or interval that the temperature for all coffee would be. Now let's check ourselves on StatCrunch. So on StatCrunch, we're going to go Stat. So let's see, T-stats. Remember, T-stats is for mean because our T critical value. One sample with summary. Our sample mean for this problem was 162. Our sample standard deviation was 10. Our sample size is 16. We're doing a confidence level, and we're going to change the 95 to 98% level. We're going to go ahead and hit compute. There we go. And you can see our degrees of freedom was 15. Our lower limit was 155.49 if we, 50. If we go to 1 decimal places, I guess it's more accurate, 168.5. So we confirm our answer. If you're wondering why it's slightly off, because don't forget we're rounding the critical value to 3 decimal places. That's why it's rounded. Okay, so good. Hopefully that helps.